Hello students, I am Miss Charisse Rizon and I will be helping you learn about random variables and probability distributions. In this video, you will learn how to illustrate a random variable, distinguish between a discrete and a continuous random variable, find the possible values of a random variable, illustrate a probability distribution for a discrete random variable and its properties, and compute probabilities corresponding to a given random variable. I hope you are as ready as I am to learn and have fun. Don't forget to pay attention and listen actively. Enjoy! When we were young, or even until today, we sometimes think of betting in the lottery or guessing the weather the next day. Sometimes we get it right, but most of the time we don't. This uncertainty can be quantified through the notion of probability. Probability is the study of mathematics that deals with how likely an event is to occur. It describes the likelihood of an event through numbers, with 0 being impossible and 1 being certain. The probability of an event is determined through experiments. Experiments are activities that result in an outcome like tossing a coin, spinning a wheel, or picking a heart in a deck of cards. Experiments have what we call a random variable. In simple terms, a random variable is the actual outcome of an experiment, denoted by uppercase letters. Lowercase letters denote the possible values or specific outcomes of the said experiment. For example, let capital letter X be the number of red marbles we draw out of a bag, while small letter x is 3 red marbles or 5 red marbles. A random variable has 2 types: the discrete random variable and the continuous random variable. A discrete random variable is a variable that is countable, like the number of chairs in a factory or the number of doctors in the COVID ward. While a continuous random variable takes on values that are on a continuous range, like the height of your child or the temperature of the student. Now let's try to check whether or not you have understood the concept of discrete and continuous random variables. Let's determine what type of variable is shown in each picture. Your time starts now. The first picture shows time, which is not countable, meaning this is continuous. The second one shows chickens, which is countable, and it is discrete. Third shows students, which is also discrete. Fourth shows the weight of a person, which is not countable, and it's continuous. And lastly, the sacks of flour that is discrete. Probability distribution. Probability distributions are statistical functions that describe the likelihood of obtaining possible values that a random variable can take. It can be written as P of x equals x or P of x, which respectively can be read as probability of x equals x or probability of x. Consequently, the kind of variable determines the type of probability distribution. For a single random variable, statisticians divide distributions into the two types: discrete probability distributions for discrete variables, and probability density functions for continuous variables. But in this video, we will only be focusing on the discrete probability distribution. A discrete probability distribution is a graph, table, or formula that lists all possible values that a discrete random variable can take on, along with their associated probabilities. The probabilities of a discrete probability distribution should be between 0 and 1. And the sum of these probabilities should be equal to 1. In making a probability distribution, you have to determine three important things. First, being the sample space. Second is the value of the random variable in each outcome. And third, being the probability values of each value of the random variable. Consider tossing two coins as an example. Suppose we are interested to find the probability distribution of the random variable x, which is the number of heads that show up. First, you have to determine the sample space. In tossing two coins, the possible outcomes are both heads, a head and a tail and a head, and both tails. Take note that a head and a tail is different from a tail and a head. Since these are the only possible outcomes, the total number of outcomes is 4. Or you can also let H be heads and T be tails. So you will have HH for both heads, HT for a head and a tail, TH for a tail and a head, and TT for both tails. Next step is to determine the value of the random variable in each outcome. In this case, x is equal to the number of heads. So we have this table. Since the first outcome shows 2 heads, then we write 2 for the number of heads, or the random variable x. The second and third outcomes show HT and TH, so the random variable should be 1. And the last outcome shows 2 tails, which means we write 0 as a random variable. Third, we determine the probability of each random variable. Recall that the probability of an event is equal to the number of outcomes over the number of total outcomes. Now, if we take a look at our sample space, the only outcome that shows 0 heads, or x equals 0, is 1. So the probability is 1 out of 4 outcomes. For 1 head, or x equals 1, this happens 2 out of 4 outcomes, so the probability is 2/4 or 1/2. For 2 heads, or x equals 2, this happens only 1 out of 4 outcomes, so the probability is also 1/4. In conclusion, this is now how the probability distribution of tossing 2 coins looks like as a table. Looking at the probabilities closely, we can see that each probability is between 0 and 1, and their sum is equal to 1, which satisfies the properties of the discrete probability distribution that was discussed earlier. You can also express the probability distribution as a graph. Our next example is to find the probability distribution of the sum of the numbers that show up when a pair of dice is tossed. For the sample space, here are all the outcomes. We have 1, 1, 1, 2, and 2, 1, 1, 3, 2, 2, 3, 1, and so on. The total number of outcomes for this example is 36. For the specific values of the random variable, here is a table that shows the outcomes and the values of the random variable x, which is the sum of the numbers shown on the upward face of both dice. If both dice show 1 and 1, the sum, or the random variable x, is 2. If both dice show 1, 2, or 2, 1, the random variable x is 3, and so on. This next table shows the probability of each value of the random variable. The probability of getting a sum of 2 is 1 out of 36 outcomes, which is the same probability of getting a sum of 12. We can see that there is more chance of getting a sum of 7, which is 6 out of 36. Therefore, this is now the probability distribution of the sum of the numbers when a pair of dice is tossed. Now, to see if you really have understood our examples, let us try this activity. You will be given 20 seconds, but you can pause this video if the given time is not enough. Time starts now. Here is the solution to our activity. First, the sample space. Let R represent the red balls and N represent the non-red balls. When we pick 3 balls from a bag, we will have the following outcomes. Thus, the total number of outcomes is 8. Second, we determine the specific values of the random variable y, which is the red balls. If we pick 3 red balls, we assign the number 3 in the random variable y. If we pick 2 red balls and a non-red ball, we assign 2. If we pick 1 red ball and 2 non-red balls, we assign 1. And if we pick no red balls, we assign 0. Third, we determine the probability of each value, therefore giving us this table. In conclusion, the probability of picking 0 and 3 red balls out of a bag is 1 out of 8, and picking 1 and 2 red balls is 3 out of 8. I hope you all have learned a lot about random variables and probability distributions through this lesson. Thank you so much for your open minds and listening ears. I will see you all in our next lesson. Bye!